Hi friends, today let us discuss about one-sided limits. Earlier we were discussing for limits to exist when we are approaching a function from the left or from the right, the function should approach a common value. Okay, so now one-sided limit is actually related to this. When we say when we are approaching from the right, let's say we are approaching this 0, x is approaching 0 from the right. So how do we mention? X is approaching 0 plus. Okay, that means we are approaching like this. Okay, we write it like this 0 plus. When we are approaching from the left, we will write it as 0 minus. Okay, x approaching 0 plus or 0 minus or whatever value that is. If it is 10, then 10 plus and 10 minus. 10 plus means we are approaching from the right, 10 minus means we are approaching from the left. Now let's take this function x by absolute value of x. Right, absolute value of x is always positive. So as long as x is positive, then this value will be equal to 1. As long as x is negative, this value will be equal to minus 1. For example, minus 2 by absolute value of minus 2. This is minus 1. Obviously, at x equal to 0, both are not defined. Now, when we are approaching this 0 from the left side, when we are approaching, as long as x is lesser than 0, and we are approaching from 0 from the left hand side, so we'll write it as limit x tends to 0 minus this y, f of x. Then this we'll call it as minus 1. When we are approaching from the right side, we'll call it as plus 1. So obviously, left hand limit and right hand limit are not matching. So overall, this function doesn't have a limit at x equal to 0. Right. Similarly, let's take this case. This is a semicircle. Semicircle, the equation of the semicircle is y equal to under root 4 minus x square. Obviously, this is defined as long as x is lying between minus 2 and plus 2. Right. Beyond 2, this becomes negative. Beyond minus 2 also, this becomes negative. So this is not valid. Right. Now, let's say when we are talking about limit here, we are talking about approaching 2. Approaching 2 from the right hand side, it is limit is not existing. From the left hand side, it is existing. What does that mean? So, approaching 2 from the left hand side, that is 2 minus, that is this. Okay, approaching 2 from the left hand side, that is 2 minus this one. Then what is the function? Function is approaching the value of 0. Right. So we'll call it like this. Similarly, approaching minus 2 only from the right hand side, it is valid. From the left hand side, it is limit is not defined. Right. So what we'll say minus 2 plus. Please note the superscript. We'll call it minus 2 from the right hand side. So this is also equal to 0. So obviously, if when a function has a limit, what that means is right hand limit should be equal to left hand limit. Then only we can say the function has a limit. Let us take some more examples. Let us take this example. This function we are defining as y equal to 0 as long as x is less than or equal to 0. And when x is greater than 0, we are defining it as sine 1 by x. Earlier we discussed about this function sine 1 by x. As x approaches 0, the function will fluctuate a lot. Will fluctuate a lot, right? Because 1 by x becomes larger and larger, larger and larger. This fluctuates very, very rapidly, right? Even a small change in x, 1 by x will have a huge change. That's why there will be so many waves, right? Now, here we can see, does limit x tends to 0 plus f of x exist? 0 plus means we are approaching from the right. No, there is no limit, right? Because we can't point out any single value. If you say this is the limit, earlier we discussed, then the entire we should be able to restrict. Uh, so when someone says there is an epsilon like this, okay, epsilon like this. Let's say we define zero point 0.5 as the limit. Then if someone defined between zero point 0.1 and within the range of zero point 0.1 on either side of zero point 0.5, the function should exist. We are not able to define any delta within which the entire function is lying within this range. Right, this is essentially fluctuating a lot. So, so there is no limit from the right hand side. Right. What is the limit? Limit. What is the precise definition? For every epsilon, whatever small it is, f of x minus limit. If there is a limit, absolute value of this should lie this less than epsilon as long as x minus x naught is lying is within some delta. We should be able to give some delta, right? If we claim that this is the limit, and then if someone says for this epsilon plus or minus in this range, if someone says in this range, give me a delta, that let's say we are talking about x naught. X naught is 0. Give me a delta where the entire function, the value of entire function, the value of the function, one x is within this range. Within this range. Let's say we call some delta as this. Within this range, the value of the entire function should lie between these two lines. But here, whatever delta that we give, so there will always this function. So this value is crossing these lines, right? Or this value is actually crossing these lines. So we cannot give some delta. We cannot restrict some delta. Whatever small delta that we take, this spike will always be there. This spike will always be there. So we cannot actually restrict for epsilon. If someone gives us epsilon of zero point 0.1, we cannot restrict the value of the function to lie within zero point 0.6 and zero point 0.4. Let's say if you assume that zero point 0.5 is the limit, right? We cannot force the function to exist in this point. Basically, what we are saying informally, what does that mean? The function should get closer and closer to the limit, right? The distance should come closer and closer. So even if there is a fluctuation, the fluctuation should become smaller and smaller. Okay. Basically, the function should approach whatever this limit as close as we want. Here, here it is, we cannot make it as close as we want, right? Because it is continuously fluctuating. We cannot reduce the distance from here to here, right? So, 0 plus limit doesn't exist, but 0 minus, this is approaching 0, 0 minus the limit exists. What is that limit? The limit is 0 only. But extends to 0, does limit exist? No, because RHL, right hand limit, is not equal to left hand limit. Right hand limit doesn't even exist, left hand exists, but these are not equal. So that's why this function doesn't have a limit. Let's take one more example. Okay, so this is again sin x multiplied by root x. Okay, sin 1 by x, sin 1 by x, we discuss it. This fluctuates a lot. This fluctuates a lot. Earlier, what is the difference? It is actually sin and 1 by x is multiplied by 1 here. Right. Here, what we are doing, we are multiplying with root x. Sin 1 by x, because this is still a sine function, will always lie between 0 and 1. Okay. And if you are multiplying with root x, obviously lie between, this will always lie between root x and root x, minus root x and plus root x, right? Because this is always lying between 1 and minus 1. We are multiplying with root x. Obviously, this should always lie between minus root x and plus root x. So that's why this is the lower bound and this is the upper bound. So now we can use the sandwich theorem. What does sandwich theorem say? It says if the function uh, is lying between two functions, right? F of x is lying between g of x and h of x, whatever. If this function, the limit is something, and if this function, the limit is the same thing, then obviously whatever in the middle function, that should also have the same limit. This is what our sandwich theorem says. Obviously, root x is approaching 0, minus root x is approaching 0 as we are approaching from the right hand side, right? So obviously, what does that mean? Root x into sine 1 by x should approach 0, right? This should approach 0, and it is little bit intuitive also, right? Sine 1 by x, whatever you do, it should always lie between minus 1 and 1. As x becomes smaller and smaller, we are multiplying with a number closer to 0, so obviously it should get closer to 0. But in the earlier case, we are multiplying this number with 1. So that's why even though the range is between minus 1 and 1, it is not getting close to 0 or anything. But here in this case, this number will always lie between minus 1 and 1. And as we approach 0, we are multiplying with a very, very smaller number. So that's why this will approach 0. Okay. So this exists and this is 0. But x tends to 0 minus. Here the function itself is not defined. Right, the function itself is not defined because root x is not defined. So this doesn't exist. Right. Now, here, does overall limit x tends to 0 exist? It doesn't exist because for it to exist, we want right hand limit should be equal to left hand limit. Left hand limit is not possible, so this also doesn't exist. Right. Now let's take another case. We are given this function f of x equal to x cube when x is not equal to 1 and 0 when x equal to 1. We have to graph this function and then find x tends to 1 minus and x tends to 1 plus. What is the limit? Okay, graph of x cube is like this, right? We know this graph, right? X cube is an odd function. What does that mean? Whatever positive values of x, that will be a reflection of with respect to the origin. That means if you rotate this graph by 180 degrees, we'll still get the same graph. That is the graph of x cube. Because minus x cube is minus of x cube, this is minus of f of x. Right? This is an odd function. Whenever odd function is there, what does that mean? The graph which is there on the positive side of x is is a reflection of the graph which is there on the negative side of the x. The reflection is with respect to the origin. It is symmetric with respect to origin. Okay, if it was just x cube. Now here when x equal to 1, this is artificially made to be equal to 0. So this point has become, this point is vacant here, but it is taking this place. Okay, now what is the question? X tends to 1 minus. That means from 1, left side of 1. We are approaching it like this. The function is clearly approaching 1. Similarly, 1 plus also, where we are approaching from the right side. X we are approaching from the right side. The function is approaching 1 again. Okay, so this limit exists. This limit exists. So see, limit doesn't mean f of 1. Okay, f of 1 is different. F of 1 is still 0. But limit exists. Limit exists means how is the function approaching from the left hand side or from the right hand side? And we cannot just, f of 1 will not be equal to 1, f of 1 is 0, but as close as this 1, this y, this 1, whatever, however close value you want, we can get, right? That means 0.99 or 9999 or 1.01 or 001, whatever, we'll get as close to 1 as we want. Okay, so even this fits the precise definition. So limit extends to 1 minus and 1 plus both exist, and that's why this limit also exists. Okay. Now, next one, let's see. 1 minus x square. 1 minus x square, when x is not equal to 1, and when x equal to 1, it is 2. The graph is an inverted parabola because the coefficient of x square is negative. So it is inverted parabola, firstly, inverted parabola, and it is meeting y-axis at 1. Okay, it is something like this. Y-axis at 1, and basically it is what is this? How do we draw this graph? X square is this, minus x square is inversion of this, and minus x square plus 1 is this graph shifted 1 unit upwards. Okay, so minus x square is this graph, and plus 1, f of x plus c, is graph shifting upwards. So this is symmetric with respect to y-axis. That means this is an even function. Right, now 1 plus, x is tending to 1 plus. That means from the right hand side, this is approaching 0. Right, this is approaching 0. 1 minus, here also this is approaching 0. Okay, find 1 plus and 1 minus. Then obviously limit, because both are approaching zeros, this is approaching 1 means the graph is approaching 0 from both the sides. So limit x tends to 1 exists, and it exists. What is the value? It is 0. So f of 1 doesn't matter. Right, f of 1 doesn't matter. It is only about how the graph is approaching. Let us take few more examples of these limits. Let us take this function under root h square plus 4h plus 5 minus root 5 by h. Okay, here we cannot directly substitute h, and let's take these cases also. Okay, this is also similar. We cannot directly substitute this h. Okay, or even minus 2 plus or minus 2 minus, we cannot directly substitute. In the cases, what should we do? Okay, so when h tends to 0 plus, what we do? We do the rationalization. We'll multiply with this with its conjugate. Okay, that is under root h square plus 4h minus root 5. The conjugate of this is plus root 5. Plus root 5 and plus root 5 will do it. Why we want? Because we want to eliminate h in the denominator. How do we do this? This is in the form of a square, a minus b into a plus b, a square minus b square. So this 5 and this one will get cancelled. Here we'll get h into h plus 4. This h and this h will cancel as long as h is not equal to 0. H is approaching 0. So basically what we are trying to say, this function is identical to this function, that is h plus 4 by under root h square plus 4h plus 5 plus root 5, as long as h is not equal to 0. And in this function we know how does this behave when h equal to 5. So this function is very identical to this function, though we don't know what exactly value of this function when h equal to 0. We'll take this as proxy. Okay, this function behaves like this, and this function is defined at h equal to 0. What this function has a limit. At the same time, this function let's say is f of 0 is defined. Okay, and limit h tends to 0, f of h is also defined. Both are same basically. So if this is some g of h, we'll take this f of h as some proxy to this function and say that yes, limit is this. Now here we have cancelled this. We'll just substitute h equal to 0 here. 0 plus 4 by, again, these two will become 0, root 5 plus root 5, right? That is 2 root 5. 4 by 2 is again 2 by root 5. So the value of limit as x tends to 0 plus is this. Similarly, 0 minus. 0 minus, it's a different function. Again, we'll multiply with the conjugate. Conjugate of root a minus b is root a minus root b is root a plus root b. Right. So we'll do root 6 plus whatever this expression. Again, a minus b into a plus b, a square minus b square. So this 6 and this 6 will get cancelled. We'll be left with minus of 5h square plus 11h. We'll take h common and this h and this h will get cancelled. We'll be left with 5h plus 11 by under root 6 plus 5h square plus 11h plus 6. This function is defined at h equal to 0 also. So let us substitute this one. Then this becomes 0, only 11 will be left. So numerator minus 11 and this will be 0, this will be 0, will be left with 2 root 6. So this becomes minus 11 by 2 root 6. Okay, let us take one more example. This one, minus 2 plus. Okay, obviously the denominator is becoming 0. We cannot, what we do here, there is an x plus 2 absolute value of x plus 2. Okay, and the denominator is normal x plus 2. Okay, when here this is 0 and this is minus 2. What we are saying, this is approaching from this side. This is approaching from this side, right? When we are approaching from the right hand side, please look at this value, absolute value of x plus 2. This will be a positive one. Okay, right. For example, if you are approaching from the right hand side, for example, if x is minus 1, then this becomes minus 1 plus 2, which is positive. Or minus 1.9, then also 2 minus 1.9, this is a positive number. So x plus 2, as long as we are approaching from the right side of minus 2, we'll say this is a positive number, so we can replace with x plus 2 by x. We can replace this with x plus 2. These two will get cancelled. Basically, this function is very identical to x plus 3 as long as we are approaching minus 2 from the right hand side. Right, guys? So, though we cannot directly say what is the value of this function at x equals to minus 2, we'll take this proxy. Okay, we'll take this proxy, and this function is actually defined at x extending to minus 2. We'll just directly substitute minus 2 here. This is equal to 1. Okay, so the important thing is we have to see how this absolute value function will behave. Right? Will it be positive? This x plus 2 by x plus 2, absolute value of x plus 2 by x plus 2, is it positive? If it in this case it is positive, that is why it is giving plus 1. If it is a negative, then it would have been negative of this thing. For example, in this case. Okay, if we are approaching from this side, if we are approaching this from this side, then what does that mean? X is lesser than minus 2. So, for example, minus 3. Then this becomes minus 3 plus 2 is minus 1, which is a negative number. So, this becomes absolute value of x plus 2, absolute value of x. When x is less than 0, what we'll call? We'll call it as minus x. So, absolute value of x plus 2 is minus of x plus 2. So, this and this will get cancelled now. Now, this function, the proxy of this is minus of x plus 3. Right. The proxy of this is x plus 3 when we are approaching from the right hand side. When we are approaching from the left hand side, the proxy is this. So this function, the limit is actually minus 1. Okay, this limit is minus 1. Clearly, this LH left hand side limit and right hand side limit are not matching. Okay, because though the function is same, both are approaching two different values. So the limit doesn't exist when x approaching minus 2 for this function. Okay, let us take one more example. In this case, again, x is approaching from 1 plus. We are talking about this is 0, this is 1. We are approaching from the right hand side. So x minus 1 will always be positive, right? So obviously, absolute value of x minus 1 is x minus 1. So we can cancel this, and this becomes root 2x, which is root 2. And when we are approaching from the right hand side, when we are approaching from the left hand side, this one will become negative. So this becomes absolute value of x minus 1 is minus of x minus 1. These two will get cancelled. So we are getting minus root 2x. So what is the limit? Limit is when you substitute x equal to 1, it is minus root 2. So clearly these functions limit doesn't exist because left hand limit and right hand limit are not matching. Okay, because of this absolute function. Let us take one more example. In this case, greatest integer function of theta when theta tends to 3 plus. When theta is 3 plus, what does that mean? The function is something like the value of theta is like 3.1, 3.2, whatever. Whatever all of this, the value of greatest integer function of theta when it is slightly higher than 3 is 3. So 3 by 3, it should be equal to 1. Similarly, when it is 3 minus, when it is 3 minus, what does that mean? Minus 3.1, minus 3.2, something like this. Yeah. Greatest integer function of this is minus 4. Sorry. This is 3 minus, not minus 3. So this is 3 minus. So what is this is 0, and we are talking about this is 3. 3 minus means we are approaching from the left hand side, that is 2.9, 2.8, whatever. So greatest integer function of 2.9, 2.8 is what? This is equal to 2. So this is 2 by 3. Greatest integer function of theta is 2. This is by 3. So clearly this is not matching this left hand limit. Though the function is same, left hand limit is not equal to right hand limit. Similarly, let's take this case. T minus greatest integer function of t, again 4 plus. When it is 4 plus, the value of this one is 4, right? If it is 4.1, 4.2 like this. So 4 minus 4, it becomes 0. When it is 4 minus, right, like 3.9, 3.8, this becomes 3, right? So this the value of limit is 4 minus 3, which is equal to 1. Clearly, the limits are not matching. So this function, t minus greatest integer function of t, this also doesn't have a limit. Right, guys? Hope you understood this. These are very, very basic concepts of left hand limits and right hand side limits. These are important for us to calculate uh, limits in a detailed way, in a consistent way, or this is good conceptual understanding. We should have this complete clarity to go further into limits. Thank you, guys.